All right, everybody. Well, here's section 11.3, problem number 21, and it's another example of Dr. Forrester wanting you to make this intuitive leap. Remember what I'm looking for is the common ratio. See, I want to find, x to the fifth times that ratio. That will be my second term right there, right? And then x to fifth times r, that will be my second term right there, and x to the fifth times r times r times r, that will be my third. See, and the thing is, finding that common ratio is what's going to allow me to find these geometric means. And sometimes when I'm analyzing data, those data points are important. Sometimes the arithmetic mean is what's important. Sometimes it's the geometric mean. Okay, so that's what I'm looking for. What I'm trying to find is that common ratio, and then that'll allow me to find what the geometric means are, the 5 means between x to the fifth and x to the 17th. All right, well, remember, t sub 1 is x to the fifth, right? And t sub 1, 2, 3, 4, 5, 6, 7. T sub 7 is x to the 17th. And so it's really just the same thing. X to the 17th is going to equal that first term, x to the fifth, right, times the r, that's what we're looking for, and this is the 7th term. X to the 17th is the 7th term, so it's the 6th root. Well, no, it's not 6. It's r to the 6th. It's not the 6th root. It's r to the 6th. Okay. The 6th power would be the better thing to say here. All right, now r to the 6th then is going to equal x to the 17th divided by x to the 5th. I subtract exponents, right? So r to the 6th is going to be x to the 17 minus 5 is going to be x to the 12th. And now I think it's maybe just a little bit better to think about this as what r's will satisfy this, will make this true. What can I replace the r with to make this true? So I'll just show you two different ways to look at it, really. Okay. One of the ways is just to take the raise each of these sides here. What I do to one side, I do the other side, right, to the 1/6, like this. I'm taking the 6th root. This is the 6th root right here, right? So x to the 12th raised to the 1/6 is going to be x squared, right? And r to the 6th raised to the 1/6 is going to be r. And so we can see r is going to equal x squared. Now the problem here is, I believe r can also equal the opposite of x squared, because I think if we let that be r, it will work. Let's see. Let's let r equal the opposite of x squared. Okay, then we have x to the 12th is equal to the opposite of x squared, r. It's equal to r. Remember, r raised to the 6th. And you see, if you take the opposite of x squared, right, times the opposite of x squared times the opposite of x squared times the opposite of x squared times the opposite of x squared. How many of those? 1, 2, 3, 4, 5. Gotta do one more. 6. Do you see? That's going to give you the opposite sign six times. 1, 2, 3, 4, 5, 6. Right? So it's an even number. So this is going to give me x to the 12th, and so that is going to work. All right. So I want to just kind of confirm to you. So do you see how r can equal x squared, but r can also equal the opposite of x squared? So that's the common ratio. R can equal x squared, or r can equal the opposite x squared. So once I know the common ratio, now it's not very hard to find what should go in each of these terms here, because now I'm just going to take x to the 5th. Let me make a little chart here. X to the 5th times x squared, the common ratio, right, is going to be x to the 7th. All right, and now I take x to the 7th times x squared, right, and I can see it's x to the 9th. It's the next one. And then x to the 9th times x squared, and I can see it's x to the 11th. I can see x to the 13th and x to the 15th. All right, that's great. That's one of my series it could be. Okay, but now I have to account for the second series that it could be, the second possibility. And let me erase all these so I can actually write it. So I can actually write it down here. Okay, so it would be x to the 5th, and then now it would be x to the 5th times the common ratio, which is the opposite of x squared. Do you see? So that's going to be opposite of x to the 7th. So the second term would be opposite of x to the 7th. All right, now it's going to be the opposite of x to the 7th times the common ratio, opposite of x squared. And the two negatives make a positive, so I can see that this is going to be x to the 9th. Okay. And now, you're just doing this off on, probably you're just doing this in your head, but just to make sure you're tracking with me, I take the opposite of x to the 9th now times the opposite of x squared. That's what r is, so every time I multiply it by r, so I get the opposite of x to the 11th, opposite of x to the 11th, right? And then I'm going to take the opposite of x to the 11th times the opposite of x squared. I can see it's the positive of x to the 13th. All right, and we can see the pattern here, right? It's x, and then it's going to be positive 17 again. All right, and the cool thing about all of this, well, I'm just done right there. Maybe I shouldn't say anything more. You can multiply all those together and take the 1, 2, 3, 4, 5, 6, 7th root of all of those multiplied together, and that will be the geometric mean between x to the 5th and x to the 17th, which is kind of cool. But I'm not saying anything. Okay, bye.